Hey guys, welcome to our first set of notes for chapter 25. We're going to talk animal evolution and coordinates this chapter, and this is a pretty fun chapter. We're going to cover a lot of ground, a lot of different types of animals, but it's a lot of fun. So, your book starts with a little section on very early birds as an example of animal evolution that talks about dinosaurs evolving into birds, and it gives two examples to support that. The first is a really well-known fossil called Archaeopteryx. Ptero with the silent P. Ptero means wing, and arche means ancient, and so Archaeopteryx means the ancient winged one. Very cool name. And it is the first fossil discovered of what we believe to be a really early bird. And we think it lived about 150 million years ago, and it had feathers, and it also had, long claws like a dinosaur, so kind of cool. And then we have Sinosauropteryx prima, which means something along the lines of the first fuzzy Chinese dragon or something like that. Here, the first Chinese feathered dragon. There we go. And we found that in China in 1994, and it was a dinosaur that had feathers, but the feathers were really small and fuzzy, kind of like downy feathers, like if you've ever seen a baby duck or a baby goose, they can't fly with them, but they're just like adorable little fluff balls. That little fluff stuff is called down, and it's really good at insulating you against cold weather, but it's not good for much else. And so that is the feathered dinosaur from China. And those two support the theory that birds are descendants from dinosaurs. And so here's Archaeopteryx. It's just an awesome fossil, isn't it? It's just a great fossil. You get all these bones, you get these really long claws extending out from the wing, and then you get the feathers extending out here. Feathers here, and then the tailbone is real long, and there's feathers, veins of feathers extending out from that. So that's pretty cool, but it's still got this kind of long clawed kind of dinosaur look about it. But I don't know, there's a lot of birds alive today that have long claws too. They don't think it was particularly good at flying necessarily, but that it could kind of glide down from trees. And so the cool thing about a fossil is it's just bones. So when it comes to artwork and what it actually looked like, you can pretty much do whatever you want. You can do this, or maybe something like this. For some reason, all of its poses make it look like it's dancing or something, kind of showing off. It's kind of ridiculous, but that's Archaeopteryx, a very, very cool fossil, a super old fossil, and about the size, maybe a little bigger than a crow is what that would look like. So just think a chicken, really, like think a chicken with a long tail and claws and teeth, and that's what you have. It's a very cool bird. And then we have this guy, like we said, China's first fuzzy little fellow. Here's the fossil. Again, I don't know. It looks cool. I, I, somebody smarter than me says it's covered in fuzz, and I believe them. And so here you have a dinosaur that's covered in little fuzzy hairs. And he's trotting along the forest, just being cool. And we can paint him with a really cool striped tail to make him look like a lemur. Don't know why, but it's fun. And he can climb trees. Who would have known that with his gimpy little arms? Not this guy, but he can. Or also maybe he can't. I don't know. But there you have a fuzzy dinosaur. So, um, birds, dinosaurs, it's all together. Let's talk about chordates. Chordates are kind of like vertebrates, something with a notochord. Most of your chordates are vertebrates, like means they have a spinal cord and vertebrae, but not all of them are. So here's what this looks like. Chordates are bilaterally symmetrical. You can cut them into right and left halves. They are also coelomate. We have true internal cavities that comprise our gut and internal organs. We also have a complete digestive system. Think yourself, for example. Multiple organs, a hollow tube, has a beginning, has an ending. Those two holes are separate, which is a great design. And we have a closed circulatory system, which is, heart, arteries, arterioles, capillaries, venules, veins, heart, lungs, repeat. it's super efficient. It's very, very effective, especially in birds. Theirs is awesome. And it's way better than the closed circulatory system when it comes to transporting blood long distances. So there are four things you need to have when you are an embryo at some point in your life if you are to count as a chordate animal. Number one, you need a stiff yet flexible connective tissue cord that runs the length of your body. That is called a notochord. You might lose these features later, but you need to have them at one point when you're an embryo. You also need a hollow nerve cord that is going to run alongside the notochord. Think a primitive, can I use the word primitive? Maybe. A simple future spinal cord. Think that. At some point during your development, you need gill slits. Little gills, kind of like pharyngeal pouches, sort of a deal. Somewhere around your throat, you need gill slits. And at some point when you're an embryo, you need a muscular tail extending beyond the anus. Now, you and I, when we were tiny little teeny embryo humans, we had all four of these. The stiff connective tissue, we had the notochord. The hollow nerve cord, we had that too, became the spinal cord. Gill slits, we had those too, but we lost them. Muscular tail extending beyond the anus, we had that too. Tragically, we lose it as we grow up, and we don't get a super long, cool tail. Otherwise, we could look like the fuzzy Chinese dinosaur. That'd be fun. So those are the four things you need. A few animals will actually keep all four of these for their whole lives, but most of us are going to lose some of them. So here's a couple that's going to keep a lot of them. Here's your two groups of chordates that are invertebrates. They don't have vertebrae. They don't have a spinal cord, but they are still chordates because they have all four of these things they need to have. The first is a lancelet. It's kind of like a fish, but kind of like a pencil, and it's really small. It says it's got a fish-shaped body. Sure. 5 centimeters long, so 2 inches is when you're an adult. And basically, they can swim freely. They have a tail. It works. But really, they pretty much bury themselves in sediment. And they stick these little tentacles out of their mouth, and they filter feed just like, an invertebrate, like a clam or a mussel or anything like that. So they filter feed. But they've got their hollow nerve cord right here. They've got the notochord, which gives them their shape. They have a mouth. They have a separate anus. They have muscles. They have an intestine. They have pharyngeal slits, which were their gill slits. And they have kept all of these things that made them a chordate, even in the adult form, which is pretty rare. But that's one example where you cannot have a vertebrae and still be a chordate animal. So here's the other one. This little coral-looking fellow is what's called a tunicate. And a tunicate is, they have, it's a little animal with 2 holes in it. That's really all it is. It's incredibly, I don't know if I should say incredibly simple, but it's pretty simple. Only the larva are going to have all 4 of our chordate traits, and then it's going to lose it as it grows into an adult. It'll undergo metamorphosis and look different as an adult. When the larva lands, it grows into this barrel-shaped adult. And basically what they're going to do is there's 2 holes, one on the top, one on the side. They suck water in the top, and they push water out the side. And there's a bunch of mucus on the gills here that catches the food, and they're going to eat in a manner that's not that significantly different from the way a sponge eats as an animal. So that's a tunicate. Now they get that name tunicate because they secrete a layer of polysaccharides around the outside of them, and they call it a tunic of polysaccharides. So kind of like clothing, I guess, is the way you could say it. But yeah, they keep their pharynx. Their pharynx is in here. It's got gill slits. It's what catches the food. And it's a pretty easy way to make a living. Just pump water. So here's a little bigger picture of that lancelet. Cool little animal. There's the eye spot, so it can sense whatever eye spots sense. Light and dark, I guess. Little tentacles out here. Here's the pharynx, which is the opening from the mouth. Still has the gill slits. The nerve cord is still here. The notochord runs the length of the body. And it has a tail that extends just a little bit beyond the anus. And those are the 4 things you need to be a chordate. So I guess it's a cool animal. I don't know. I've never actually seen one. And then here's a much nicer picture of that tunicate. These little guys I showed you back here were the tunicates. This is the zoomed in picture. Look at, isn't that thing just weird? Whole animal. That's it. That's it. This is the larva, which is a little cooler. It's got the pharynx, it's got the gill slits, it's got a nerve cord, like its little spinal cord basically. It's got a notochord, and it's got this little tail. And he swims around, and he lands, and when he lands, he grows into this big barrel. And we got water flowing in, goes over the pharynx and the gill slits. A bunch of food gets caught up in this mucus in here. When it does, it's transported down to a little simple stomach. We got a little circulatory system attached to that stomach. Pump a little blood up here, pump a little blood down there. Waste particles pushed out here. Water flows out. Poof. You've digested. Very, very simple. And it keeps those gill slits even when it's an adult, which is kind of a cool trick. And just, I don't know. What do you say about a tunicate? Weird animal. Let's say that. Okay, so when we look at chordates, what we're really going to be interested in, not to say those other guys aren't interesting, because they are, but we're going to be interested in vertebrates, because we're vertebrates, and we're selfish, and we think we're interesting. And the cool thing about being a vertebrate is when you have vertebrae, you have an endoskeleton, a skeleton within you, and skeletons within you can grow with you, and that's awesome because exoskeletons are a huge pain in the neck, because as you grow, there's not enough room, and you must molt this like a crawdad or a bug and pull yourself out of your old body and grow a new skeleton, and that's very annoying. So we have one inside of us that just grows with us, and it's an awesome feature because we can grow very tall in our vertebrae and long bones, they'll just grow right with us. So our first vertebrates we believe were fish that just kind of sucked up food, and we didn't have true jaws. And then later on the scene, we got a hinge in that mouth, and that hinge in our mouth worked as a jaw, and once you have a jaw, we could adapt our feeding strategies. We didn't have to just be a bottom feeder or a filter feeder. Once you have a jaw, you have the option of working a little more as a predator, and that's kind of cool. And so here's sort of the evolutionary timeline that we've thrown out for all existing vertebrates or chordates. So the ancestral chordate, he's not around anymore, but we got our lancelets, we've got our tunicates, both very simple, no spine, that kind of stuff. Now we're going to get a spine from here on out, so we get a backbone, vertebrae. Now we have jawless fishes that still exist today, and we'll talk more about those in this chapter, but they're like lamprey and other things that give me nightmares. Hagfish, I think. And then through a series of mutations, we get a hinge in that mouth, and we get jaws. And once you get jaws, you can branch off into cartilaginous fishes like the sharks. We get a swim bladder later, and we get ray-finned fishes, which is like your standard kind of what you think of when you think of a fish, is ray-finned fishes. Bass and perch and trout, that kind of stuff you catch around here in South Dakota. So once we get lungs and bony appendages, we can get some lobe-finned fishes. We can get some bones working down into these fins, which is really cool. When we get lungs, we get the opportunity to start working into moving from water to land into what are called tetrapods or four-legged animals. And we make that transition from water to land. We have four-limbed amphibians that will oftentimes still start their lives as aquatic, and then we'll move to terrestrial adults. And then we get amniote eggs, and amniote eggs are eggs that do not need to be in the water. Everything here needs eggs that need to be in the water. But starting with reptiles, we have eggs that have a watertight membrane inside the egg, and the embryo can develop inside the egg on land. And so now we've opened up this huge new opportunity of existing a long ways from water. So we have reptiles, and of course the birds that evolved from the dinosaurs. And then we have mammals, which is like you and I, who don't lay eggs, but we have the eggs in the female, and that's watertight, I guess, so it counts. So that's good. Cool. So we're going to stop at jawless fish. That's 2 sections. It's a short video, and I hope this little chart makes sense. Thanks for your time.